Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that solve the following initial value problem. This is the initial value problem. The y over the x is equal to x plus y. Then y, open brackets, y0 is equal to 0. So now, to solve this solution, the first thing we're going to do, we have to solve this differential equation. And from the look of things, this differential equation is a linear differential equation. So we're going to solve it using the method of solving linear differential equation. If it's a Bernoulli equation or a homogeneous equation, you have to solve it according to the method we use to solve Bernoulli and homogeneous, or any type of equation they give you. So you have to first solve it using the method. Now this is a linear differential equation. Since it's a linear differential equation, we have to solve it using the method of solving linear differential equations. So now first, we have to rearrange it. So the general form of a linear differential equation is given by this, dy over the x plus py is equal to q. This will be our equation 1, where p and q are constants or functions of x only. So now, we have to rearrange this to look like this. So it will be dy over the x minus y is equal to x. So from when we relate these two equations, equation 1 and equation 2, when we relate these two equations, p is equal to what? Minus 1, and q is equal to x. So, since it's a linear differential equation, we need an integrating factor. So I'll call that if for integrating factor. So our if is equal to exponent of the integral of p dx. So our p is negative 1, so it will be exponent integral of negative 1 dx. So the integral of negative 1 dx is what? Is negative x. So this will be exponent of negative x. So this is our integrating factor. Then we'll substitute this and q in this equation. We'll substitute this integrating factor and q in this equation, y p dx is equals to integral of q p dx. So this is the equation we're going to use to solve this linear differential equation. So now we have y. This is exponential negative x is equals to q. Towards q is x, negative x dx. So this is an integral of a product of two functions, x and exponent negative x. So we are going to use integration by parts, which is also known as integration of products. So let's demarcate this. Then, so the integral, we use integration by parts here. So our u is x. We'll find the derivative. The u is equal to the x. Then, the v is exponent negative x dx. We'll find the integral v is equal to negative exponential negative x. So now, the integral of this x exponential negative x dx is equals to uv, which is this negative x exponential minus x minus integral of v du, which this is v, this is the u, so it's minus exponential negative x dx. So this becomes negative x plus integral exponent negative x dx. So this becomes what? Negative x. The integral of this is negative exponential negative x plus c. So the integral of x, exponent negative x dx is this. So now we can substitute it back into the original equation. It becomes y exponent negative x is equal to this negative x exponent negative x minus exponent of negative x plus c. So now here is this exponent negative x. You can write it in this form: 1 over exponent of x equals to minus x exponent negative x minus exponent negative x plus c. So we can cross multiply. This becomes y is equals to, so this will multiply by each term. So this will be negative x. This times this will be exponent negative x plus x. So it will be 0, which is exponent of 0, which is 1. Minus here also will be 1 plus c exponent x. So now we can rearrange this as y is equals to c e raised to the power of x minus 1. So we have successfully solved this linear differential equation. Then, since we are dealing with an initial value problem, we will express this y in terms of x also. So it will be y, which is a function of x, will be equal to c minus x minus 1. Because y originally is a function of x. So we have included x. We have expressed it in terms of x also. Now, from the initial value problem, y open bracket 0 close bracket is equal to 0. This is to say, this means that x is equal to 0. Because we are finding y, which is a function, when we substitute x equals to 0. That means when this happens, it's equals to 0. So now, in the same way, we are going to substitute 0 here in the function that we have found. So when we substitute 0 here, it will be y0 is equals to what? C exponent 0. Let's write it to be y0 is equals to what? C exponent of 0 minus 0 minus 1. So this becomes, this exponent 0 is 1. So this becomes, this exponent 0 is 1. So this becomes c minus 1. So this becomes our equation A. And the second one, which was given the equation, becomes our second equation, which is equation B. So now we will solve these two together. From these two now, we will equate equation A to B. From these two now, we will equate equation A to B. Since this is common, we will say C1 minus 1, we will say C minus 1 is equal to 0. Because both of them are functions when x is equal to 0. So C minus 1 is equal to 0. We equate the two. So now C is equal to 1. So now we can substitute this C back into the original equation, which is this. So here C will be 1. So it will be, so here C will be 1. So it will be y is equal to C exponential x minus x. So here, this C here will turn to 1. So it will be y is equal to exponential x minus 1. So now, y will be equals to exponential x minus 1. So this is the final answer. Now, what I want you to know in solving initial value problems, you have to know how to solve all the types of differential equation. Be it Bernoulli, homogeneous, non-homogeneous, exact, all of them, linear, this is a linear. So you have to know how to solve all of them, because you'll be given any equation to solve for initial value problem. So, and if you don't know how to solve that differential equation, you'll not be able to apply this initial value problem. So this differential equation that was given to us is a linear differential equation. So a Bernoulli differential equation can be given to you, likewise homogeneous or non-homogeneous and others. And you must know how to identify each of these differential equations. If you have not watched, so all my previous videos on this course, mathematical methods 1, that is maths 2 and 2, I solved all those differential equations. You can check out my playlist. Didn't get this part of integration by parts. You can also check out my playlist on maths 112, that's calculus 1. I did integration by parts in one of those videos on the playlist. And then you can also express this like this. So you can also say y, then you put x is equals to exponential x minus 1. All are correct. But since we are doing initial value problem, this will be more accepted. But it's the same thing. So that's it. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.